Hey guys, hope y'all had a good Easter, and I hope y'all had a first good week of online learning. This is going to be week 2's lesson. So just like last week, the notes that I'm about to go over, that covers the notes for the whole week, and then the rest of the packet will be your work for the whole entire week. So it's just one packet again. Hopefully that worked out well last week. Remember that if you do your work, feel free to email it to me. I don't mind checking it, but remember that there are answer keys that I'm posting, so I would prefer that you check your answers on your own and then email me any questions that you might have about a problem that you might have gotten wrong and you didn't quite understand what you did wrong. But please feel free to email me if you want to. I'll be glad to help you. I'm also here to answer any questions, so please don't hesitate to email me with any questions that you might have. So last week we learned about solving inequalities. We're doing this. We're continuing that this week, but we're diving a little bit deeper. This week's work is going to be really similar to solving equations. So shouldn't be too terribly difficult. So we're solving inequalities by adding or subtracting using those properties of inequalities. Okay. Just like we used the properties of equality when we were doing equations. It was properties of equality because you had equal signs for equations, but these will be properties of inequalities because we have inequalities. We don't have equal signs there. So when you're adding or subtracting a number from each side of an inequality, the inequality remains true. So just like when we solve equations, say that we subtract 2 from one side, remember that we always have to subtract 2 from the other side, that equal sign stays there. Nothing changes with that equal sign. So that's what this is saying here. Nothing is changing with your inequality. So if I subtract 12 from this side, and then I subtract 12 from this side, this inequality does not change. It stays the exact same. Okay, so example, we've got 12 plus y is greater than 20. So right here, just like we said, we're basically pretend that this is an equal sign, and then you just have a one-step equation. Okay, so we want to solve for y. We want to figure out, okay, what is y? What would make this inequality true? So it's 12 plus y. So because this is a positive 12, we need to get rid of it or get it to the other side, so I'm going to do the exact opposite, which is to subtract 12. So that's what they're doing here. We've got 12 minus 12 plus y is greater than 20 minus 12. Remember, we subtracted 12 from the left, so we have to subtract the 12 from the right as well. So then that 12 minus 12 becomes 0, so it just goes away, and you're left with y on the left-hand side. And then 20 minus 12 leaves you 8 on the right. So y is greater than 8. So that means in order for that inequality to be true, y has to be greater than 8. So it could be 8.1, 8.2, or it could be 9, 10, and so forth. Okay. So just like when we checked equations, we're going to check our inequalities. But this is where it gets a little bit different than checking equations. You still want to write out your inequality, and you're basically just writing a little question mark saying, okay, is this true? So we said that y has to be greater than 8, so you're just going to pick a number that's greater than 8. So in this case, we picked 9. So we plugged in 9 for y. So then solving this left-hand side, 12 plus 9 is 21. So then the inequality reads 21 is greater than 20. Which is true. So that tells you that you solved the equation or the inequality correctly. Okay. Again, it does not matter. You could have picked 10 here. You could have picked 100. As long as that number was greater than 8, then you should see that you have a true inequality. Okay. All right. So I'm going to do the odd numbers down here. And I think I'm actually going to do them on a separate sheet of paper because it does not leave a whole lot of room here. So I'm going to come over here so I can write just a little bit bigger. All right, so my inequality is negative 12 is less than 8 plus b. Okay. Notice that the directions say to solve each inequality and check your solution. So you should be doing both of those. Okay, so negative 12 is less than 8 plus b. So you are wanting to get b by itself. So the number that is with b is a positive 8. So that means that I want to subtract 8 to get it gone. Okay, so if I subtract 8 from the right, I have to subtract 8 from the left. So then I'm left with, on this side, I'm left with B. That inequality symbol never changes. And then negative 12 minus 8 leaves you with, what is that, negative 20. Okay. So this reads negative 20 is less than B. Okay. Remember last week how I said that we normally like to keep that variable first? You can keep that variable first because it's going to make a little bit more sense, especially when you go plug in numbers in. So you can rewrite this as B is greater than, okay, so you still want to keep that open side closest to the B. So this inequality is just simply going to flip because we're writing it in the opposite direction, okay. So this could also say B is greater than negative 20, okay. So either or. Those are the same answers. Now we want to check it, make sure that we did it correctly. So if I'm checking it, that means I'm going to simply just plug in anything that's greater than negative 20. So remember when we get to the negative numbers, my larger numbers are actually the numbers closer to 0. So I'm just going to plug in, well actually if it's greater than negative 20, it can be a positive number, right? So I could even plug in 0 because 0 is greater than negative 20, right? Negative 20 is less than 0, so that means 0 is greater than negative 20. So you can make this super simple, and you could say that 0 is B. So I'm just going back to my original inequality. I've got negative 12 is less than 8 plus B. We're going to say that B is 0. So then I would write negative 12 is less than 8 plus 0. 8 plus 0 is just 8. So then the inequality reads negative 12 is less than 8. And that is a true statement, so you know you did it correctly. Okay. All right. Again, I'm just doing the odd numbers just to make my video a little bit shorter. If I do all of them, I know it will be super long. So I'm going to skip to number 3. And number 3 should be P plus 5 is less than negative 13. Okay. So again, you're wanting to solve for P. So if I cover up that P, I'm left, everything that's with P is a positive 5, so I'm doing the opposite. So I'm going to subtract 5. If I do it to one side, I have to do it to the other. So on here, these cancel. So I'm left with P on the left-hand side. That inequality stays the same, so you just bring it down. And then negative 13 minus 5 should give you negative 18. So that says P is less than negative 18. My variable is already on the left-hand side, so I'm not going to switch it like I did up there. So now I want to check it to see if I did it correctly. So again, you're using that original inequality that you had, so that would be P plus 5 is less than negative 13. P is less than negative 18, so a number that's less than negative 18, you can pick any. I'm just going to say negative 19. So negative 19 plus 5 is less than negative 13. So negative 19 plus 5 should give me negative 14. Is negative 14 less than negative 13? Yes, it is, because remember, like what I just said, the larger the number, the smaller it is when you're talking about negative numbers. So negative 14 is less than negative 13. Okay. All right. So again, these are my answers over here. This is just how you're checking it to make sure that you do get a true statement. Make sure that you did do it correctly. Okay. All right, number 5. I've got 21 is less than n minus negative 18. Okay, what do we know about this minus a negative number right here? Remember that two negatives right next to each other make a positive, so this is really 21 is less than n plus 18. Okay, so that's really what that is, that inequality is reading. So I'm solving for n. So it's n plus 18, so you want to get rid of this plus 18, so I'm going to subtract 18 from both sides, which leaves me with n on the right. My inequality stays the same. 21 minus 18 should leave you with a positive 3. So 3 is less than n, or since we normally prefer that variable to be at front, I can flip this all around. So that means I have n, switch this, so this is less than, so it becomes greater than 3. Okay. So when you switch it, again, it just kind of helps you to figure out, okay, what number should I be picking? Should I be picking a 2 or should I be picking a 4? Is it less than 3 or greater than 3? So if 3 is less than n, it's easier to figure out, okay, n has to be greater than 3, so 4 is greater than 3, so I can use 4 to check it. Okay. So when we do check it, I'm going to use this equation right here, not my original, since I did change it. I know that that is at n plus 18. I've got 21 is less than n plus 18. A number that's greater than 3, I'm just going to say 4. So we're going to say 21 is less than 4 plus 18. So then 4 plus 18 should be 22. 21 is less than 22, so we did it correctly. It checks out. It's a true statement. All right, number 7. Let's see. We've got 14 is greater than w plus negative 2. Okay, what is the same as adding a negative? Remember that adding a negative is exactly the same as saying subtracting. Okay, so plus negative 2. That is the same as saying just minus 2. So you're basically just getting rid of that plus sign. So this is the same as just w minus 2. Okay? And that makes it a little bit easier to figure out, okay, how do I solve for w? Okay? So because it's w minus 2, I'm doing the opposite. So that means I'm going to add 2 to both sides. So then, of course, 14 plus 2 leaves me with 16. That inequality does not change. So 16 is greater than w, because remember this negative 2 and this plus 2, they canceled each other out. They give you 0. Okay? So it says 16 is greater than w, or we can switch that around and say w is less than 16. Okay. So then we want to check it. So again, I'm going to use this 14 is greater than w minus 2. W has to be anything that's less than 16. So I'm just going to make it easy on ourselves. 0 is less than 16, right? So I'm going to say that 0 is w. So that means I have 14, which is greater than 0 minus 2. And then anything minus 2 is anything, anything minus 2 is just left with you, that 0. I don't know what I'm trying to say. Brain is dead. 0 minus anything is left with that minus anything. Okay, so that's basically like saying nothing is there. So this is a negative 2, so don't get confused and say that this is a positive 2. So this is 14 is greater than negative 2. Is that true? Yes, positive number is always greater than a negative. So it checks out. Alright, give me a new piece of paper. Hopefully y'all got that. And I'm going to move on to, what was that? That was 7, so number 9. So I have z plus -4 is less than -2.5. So you got some decimals here. So again, just like the last example, this plus and negative, that's actually just one big minus sign. So I'm going to say that z minus 4 is less than -2.5. Okay. So solving for z, I want to get rid of this minus 4, so that means I'm going to add 4 to both sides. So I'm left with the z on the left hand, because those cancel. Z is less than -2.5 plus 4, so you're actually subtracting, so what's that, 1.5? So z is less than 1.5. So now let's check it and see if it is true. So I've got z minus 4 is less than -2.5. So any number less than 1.5, so 1 would be smaller than 1.5. So we can say 1 minus 4 is less than -2.5. 1 minus 4 leaves you with -3. So -3 is less than -2.5. This is in fact a true statement. Remember, the smaller the larger. So this is larger than -3. So this is a true statement. If you get confused, like I said last week, if you get confused on the these negative numbers being less than or greater than, draw out your number line, okay? If I have 0 over here, then I've got 1, 2, and 3. So -1, -2, -3. That -2.5 would be somewhere right here, right? And then -3 is right here. So that should help you to figure out, okay, is 3 less than -2? Yes, because it's further down the number line in the negative direction. I would rather it be -1 degrees outside instead of -50 degrees outside, because -1 would be a lot warmer than -50, okay? So the further to the left direction that you go, the smaller it's getting. Okay. All right, number 11. Got some fractions here. I know y'all love that. So we got g minus 2 1/3 is, now we've got some less than or equal to's, or this is actually greater than or equal to 3 1/6. Okay. All right, so I'm solving for g. So this is a negative, so that means you're going to be adding positive 2 1/3 to both sides. So I know on the left-hand side over here I'm going to be left with g. So I've got g is greater than or equal to. And then I'm going to plug this in my calculator. And my calculator is actually the one from when I was in middle school. So this one's a little bit different than yours. And I have to kind of remember how to do it. Let's see. I've got 3 1/6. I think this is right. And then this slash. So 3 1/6 plus 2 1/3. So that gives me 5 3/6. I'm going to simplify that because it should be 5 1/2. Okay. So g is greater than or equal to 5 1/2. Again, your calculator is different. I think it's still probably the same button. No, I think y'all's button is right here. It looks a little different, but it should be that button right there. But I think y'all should all remember how to use fractions in your calculator. Sorry, I apologize. I didn't bring one of mine home from school, so I had to use one of those. already at my house. All right, so let's check this. So is it okay if I go ahead and just plug my numbers in for G instead of rewriting this? Because I know y'all are probably doing the same thing. So I've got G. We said that G has to be greater than or equal to 5 1/2. So we could choose 5 1/2 since it can be greater than or equal to. So let's just do it. Let's see what it gives me. So G, 5 1/2 minus 2 1/3 is greater than or equal to 3 1/6. So let's see if it gives me a true statement. So I'm going to keep that. So I'm just going to hit my equal button. Or, no, I'm going to hit minus 2, wrong button, 2 1/3. And it gives me 3 1/6. So is 3 1/6 greater than or equal to 3 1/6? Yes, it is actually, in fact, the equal to part. So this is a true statement. Okay. Remember that if it did not have that equal to sign, that would be a false statement. All right. Number 13. We've got negative 10 is less than or equal to x minus 5. Okay. So to solve for x, that means I'm going to be adding 5 to both sides. So negative 10 plus 5 leaves me with just negative 5. Got negative 5 is less than or equal to x. And then if I want to switch it around to make it a little easier, that means it would be x. Flip this around, so the opposite, which would be greater than or equal to negative 5. So checking, I've got negative 10 is less than or equal to x minus 5. Okay, so for x, it has to be greater than or equal to negative 5. So anything that's greater than negative 5 will work for this. So let's just say 1. So let's say 1 minus 5. So negative 10 is less than or equal to 1 minus 5 should give you negative 4. So is negative 10 smaller than negative 4? Yes, it goes with that less than part right there. It's not equal to, but it is less than, so it is a true statement. Okay, number 15, just a few more and we'll flip over. We've got 20 is less than m minus 6. So to solve for m, I'm going to be doing the opposite of minus 6, so plus 6 to both sides, which gives me 26 on the left hand, and then just m. So 26 is less than m, or m is greater than 26. Okay, so now let's check it. So I've got 20 is less than m minus 6. So m has to be greater than 26. So let's just say 30. 30 is greater than 26, right? So 30 minus 6. So then 30 minus 6 should leave you with, what, 24? So 20 is less than 24. Is that true? Yes, it is. So it's a true statement. It's a true inequality. And last one, number 17. I've got, I think that's a k, plus 5 is greater than or equal to negative 7. Alright, so k plus 5, to solve for k, I'm going to subtract 5 from both sides. So that leaves me with k is greater than or equal to negative 7 minus 5 should give you negative 12. So k is greater than or equal to negative 12. So let's see if that's correct. Okay, so what's a number greater than or equal to? So you could use negative 12 here, Or you could pick something a little bit easier, a positive number, because any positive number is going to be greater than a negative number. So let's just say 1. So 1 plus 5 is greater than or equal to negative 7. 1 plus 5 is 6. Is 6 greater than or equal to negative 7? It is greater than, because like I just said, a positive number is always going to be larger than a negative number. So that is a true statement. All right. We're going to flip over. I know this video is getting a little longer than last week. Sorry about that. We're going to flip over to the next page in your packet. It should look like this. So this is solving inequalities by multiplying or dividing. So that first page was adding or subtracting. Here we're just multiplying or dividing, okay? So we're still using the multiplication and division properties of inequalities to solve them. So it says when you multiply or divide each side of an inequality by a positive number, the inequality remains true. So I want y'all to underline that. This is important. When you multiply or divide by a positive number, the inequality remains true. Okay? Which means, just like what we were doing on the first page, your inequality sign does not change. Okay? For an inequality to remain true when multiplying or dividing each side of the inequality by a negative number, however, you must reverse the direction of the inequality symbol. So, they worded this a little bit differently. In order for it to remain true when multiplying or dividing by a negative number, okay, you must reverse the direction. So that means if, say, if you're dividing, so if you have, I don't know, 2x is less than 72, when you solve that, or negative 2x is less than, you would flip the sign. So the less than would become greater than, okay? So if you're dealing with positive numbers, okay, nothing changes if you are multiplying or dividing by a positive number. So nothing changes. If you want to make, uh-oh, my orange marker is going out. So positive number, nothing changes. Okay. If it's a negative number, if you're multiplying or dividing by a negative number, you reverse the symbol. Yeah, we can just say reverse the symbol. Okay. So positive is easy, nothing changes. If you're dividing or multiplying by a negative, you're just flipping flipping the symbol. So a less than would become a greater than, or a greater than would become a less than. Okay. So let's look at an example. We've got 8x is greater than or equal to 72. So still just act like this is a one-step equation, okay? If this was an equal sign right here, you know exactly what to do. 8x is greater than or equal to 72. In order to solve for x, you're doing the opposite. So this actually means 8 times x. So the opposite is to divide, okay? So 8x divided by 8. You divided the left hand, so that means you have to divide the right hand. Okay, so then you're left with x over here. I divided by a positive number, so that inequality does not change. It is still greater than or equal to. And then 72 divided by 8 gives you 9. Okay, so this says that x is greater than or equal to 9. And then, of course, you can always check it just like we did on the first page. Okay, so you would just say, okay, any number that's greater than or equal to 9. So you could simply say 8 times 10, because 10 is greater than 9, right? So you could say, okay, 8 times 10, is that greater than or equal to 72? Should be. 8 times 10 is 80, so 80 is greater than or equal to 72. Okay, so you're checking them the same exact way. All right. Example number 2. You've got y divided by negative 12 is less than 4. They want us to graph this solution on a number line as well. Okay. So y divided by negative 12, in order to solve, this is a division problem. So to get rid of that negative 12 so that you just have y, you should be multiplying. Okay. So you're multiplying negative 12, both sides. Okay. So negative 12 times negative 12 is what leaves you with a y. Okay. Negative 12 times 4 is negative 48. Okay. What happened here? It started off with a less than, but then it changed to a greater than. We changed to a greater than because, remember, we were multiplying by a negative. Okay. So because we multiplied by a negative, we went ahead and changed it as soon as we started multiplying, okay, so that you don't forget about it. So this now reads y is greater than negative 48, okay? So we started with a less than, and then it switched right here to a greater than because we multiplied by a negative number, okay? Can't forget to switch that when you're multiplying or dividing by a negative. And then graphing the solution, we know how to do that from last week. This is a greater than sign, so I know it's going to be an open circle. And then your line is following in the direction of that sign. So it's everything greater than negative 48. Okay. All right. So the main thing you have to remember is, okay, is it a positive number that I'm multiplying or dividing with? Okay, nothing changes. It is exactly the same. Do it exactly like you know how to. If it's a negative number, you're simply just flipping that sign, okay? All right, so number 1, 81 is less than 9D. All right, so I want to solve for D, okay? So this is 9 times D. So in order to solve for D, you're going to do the opposite, which would be divide, okay? You're dividing both sides by 9. So then that leaves me with 81 divided by 9 is what? Should be 9. So 9 is less than, it's a positive number, so this does not change. And then 9D divided by 9 was D. So 9 is less than D. Or this is where it's important that you change it, because if you're going strictly off of drawing your line in the direction of your symbol, if you don't switch your D to become the first, it's going to be opposite of the way the symbol is, okay? So I'm going to go ahead and write this as D is greater than 9, okay? So because it's greater than, it's an open circle. And then everything greater than 9. So you should be coloring to the right of that. Okay? Do you see what I'm saying here? If you don't switch it and you're going just off of this direction, then you would have put an open circle here and you would have colored everything in the left direction, which would be incorrect. So in order to go off of the direction of your symbol, your variable has to come first. Okay. All right, number 2, P divided by 3 is less than negative 12. So to solve for P, it's division, so I'm going to be multiplying. So I'm multiplying both sides by 3. Not a whole lot of room here either. So then you're left with P is less than, okay, I multiplied by a positive number, so remember this stays the same. It's a negative number over here, and that's okay. Nothing happens when you have a negative over here. It only changes when whatever you're dividing both sides by is negative, okay? So in this case, it stays the same. So negative 12 times 3 is negative 36. So P is less than negative 36. So that means it's going to be an open circle on negative 36, and it's everything less than that, so smaller to the left direction. Okay. All right, number 3, I've got H divided by negative 4 is greater than or equal to 3. Okay, in order to solve for H, we're dividing by negative 4, so that means I need to multiply by negative 4. Now this is a negative number we're dealing with that we're multiplying by. So this is when you need to flip that sign, okay? So over here on this side, I should have H. I had greater than or equal to. That is now going to become less than or equal to. And then 3 times negative 4 is negative 12, okay? So you have to remember to flip or reverse that sign because we were multiplying by a negative number. So in this case, it's less than or equal to, so it's going to be a closed circle on negative 12, and it's everything less than that or equal to, so in the left direction. Number 4, negative 20t is less than or equal to 100. So to solve for t, I would be multiplying because I'm multiplying already, so that means I'm dividing. So I'm dividing by negative 20. Because I'm dividing by a negative number, that sign is going to reverse. So now I should have t is greater than or equal to. 100 divided by 20 is negative 5. So t is greater than or equal to negative 5. Okay. Greater than or equal to, so that means a closed circle. And then that should be everything in the right direction. Number 5, I've got another fraction here. Remember, this is a number times a number, okay? So just because you have a fraction here, that doesn't mean that you're dividing. It doesn't mean that you're multiplying or anything, okay? This is a number times a number. So negative 2/3 times x. So I'm multiplying here. So how would I solve for it? I would divide by the number there. So I'm dividing by negative 2/3. Okay. Because it's a negative number I'm dividing by, this is now going to switch to a less than symbol. You have x is less than 12 divided by negative 2/3. Which is negative 18. So x is less than negative 18. Remember, we haven't been checking these mainly because I didn't have a whole lot of room here. But remember, you can check these just like how I showed you on example 1. Okay. So x is less than negative 18. It's a less than, so open circle and everything in the left direction. Alright, number 6, I've got negative 16 is less than or equal to negative 1/4 b. So again, this is negative 1/4 times b. So you're going to be dividing by negative 1/4 on both sides. We're dividing by a negative, so that less than or equal to is going to become a greater than or equal to. Okay. So negative 16 divided by negative 1/4 is actually like saying negative 16 times 4. So that is 64. So 64 is greater than or equal to. I've got to reverse that. Greater than or equal to b. Okay. This is another one of those that the variable is first. It's not first, so we want to switch it to where it is first. So 64 needs to come over to the other side and be switched. So let's say that actually would be b is greater than or equal to 64. So it's a little bit easier to draw your graph. Okay. All right, so it's greater than or equal to, so closed circle on 64, and should be everything in the right direction. Alright, almost done. Sorry about this long video. Number 7. Negative 8 is less than c divided by negative 2.5. So I'm dividing, so that means to solve for c, I'm going to multiply by negative 2.5 on both sides. So Negative times a negative is a positive, so 8 times 2.5 should be 20. I'm going to write it down here. So I've got 20. Did I multiply or divide by a negative? I did, so that less than should become a greater than. C. You want to get that variable first. So flipping it, we can say C is less than 20. So then that means an open circle goes on 20. And then less than 20, so everything in the left direction. And the last one, n divided by 3 is greater than 0.5. So we're dividing here to begin with. So to solve for n, that means you're going to be multiplying. So you're multiplying both sides by positive 3. It's a positive number, so that is not going to change. It's going to stay greater than. Okay. So this becomes n. That stays the same. So n is greater than 0.5 times 3, which should be 1.5. So n is greater than 1.5. Okay, so my number line is in whole numbers, so 1.5 would be somewhere right here in between 1 and 2. It's going to be an open circle, and then everything greater than, so to the right direction. Alright, so remember, if you're multiplying or dividing by a negative, that's when you are going to reverse that symbol. Okay? If it's a positive number like we just did, it stays the same. You don't do anything differently. Okay? So this is similar to your equations. You can check them. Make sure that you are checking them at least to begin with until you kind of get the hang of it. And then make sure that you are remembering those closed and open circles. Okay? All right, again, if you have any questions while you're working on this work throughout the week, please feel free to email me. Just like last week, it tells you kind of what to do. So, since my video was kind of longer today, you shouldn't really have to do anything. You can just watch the video and fill out your notes. Tomorrow you can do the evens, and then Wednesday you can do the odds, and then that last page, Thursday and Friday, evens and odds. Okay? All right, hope y'all have a great week, and hopefully I will talk to y'all shortly.